Hello teachers! Let's talk about 7-3 repeating decimals. So what are we going to do this time? We're going to cover why repeating decimals occur and how to tell if a decimal will repeat, how a fraction can be converted to a repeating decimal and vice versa, ordering repeating decimals efficiently, and that 0.9 or how do you even say that, right? Because it's not like you can say 9/10, but the decimal 0.9999 going on forever really does equal 1, and investigate various ways to show this is true. So we have examined decimal numbers such as 475 thousandths, which stop and are called terminating decimals. So if you have a decimal that has a real end point, that is a terminating decimal. Not all rational numbers can be represented by a terminating decimal. We know this, right? Because what's 1/3? It's a rational number, but you know what the decimal for that looks like. 0.33333. It goes on forever and ever, and that is not a terminating decimal. So for example, converting 2/11ths into a decimal using the long division process indicates that we will actually get 0.18181818 forever, with the digits 18 repeating over and over indefinitely. So how could you convert a fraction into a decimal? You just divide. And so you can use long division like we have over here on the right in this problem, or you could use your calculator. And again, I encourage you not to use your calculator as often as possible, but sometimes now, you know, if you have to do long division a lot, your calculator can come in handy and actually be a wonderful learning tool, so you don't have to do this long division over and over again, and you get to see lots of examples. You get to show your students lots of examples. A decimal of this type is a repeating decimal. So a decimal, for instance, again on the previous page, 0.18181818 goes on forever. That pattern continues. And the repeating block of digits is called the repetend. That's a cool word, right? Repetend. The repeating decimal is written as 0.18. You notice the bar that's over the 0.18, okay? That means, again, the 1/8 repeats continuously. If the bar was just over the 8, then the decimal would be 0.188888. So make sure you pay close attention to what digits are under the bar, and that's the repeating part. The repetend, where the bar indicates that the block of digits underneath is repeated continuously. So I have an example right off the bat for you. This is example 10. Use a calculator to convert the following decimals. And so it told us we could use a calculator. There's a similar problem in your homework. Feel free, unless you would like to practice your long division, which is not a bad idea, feel free to use a calculator. So I'm going to do in my calculator 1 divided by 7. So make sure you realize what you're doing here too. That's 1 divided by 7 in the calculator. And this is what it tells me. It says 0.1428571443, and that's the last digit I have. Now what's really going on here is, if you'll notice, 142857, 14, the 3 was originally the 2 and the 8 after it, so it got rounded. Turns out this decimal is 0.142857, and that entire, forgot the 7, that entire list of numbers there is the repetend. Okay, how about 2 divided by 13? So again, in my calculator, you take numerator divided by denominator. So 2 divided by 13 is equivalent to 0.15384614. Do you see the repetend in there? So 15384615. Possibly that 4 was 38. So this is the part that's repeating. And what I should do is put a bar over all of that. Okay, and then just leave off the 5, so I didn't recopy it. Now I have the typed up version of that. See if that matches what we said. So there's that first one, 142857, and there's the next one. Now, how do we know this is happening? Because if you type this in your calculator, how do you know that this is a repeating decimal versus it just terminates at that 7 or at that 6? How do we know? Remember, excuse me, 2 sections ago, we talked about repeating decimals have prime factorizations only with a 2 and a 5. But this prime factorization of a 7 is just 7. The prime factorization of 13 is just 13. So there are no 2's and 5's here. Therefore, we know that even though this is a rational number, it absolutely is, that we have a repeating decimal. Okay? So once you know ahead of time this thing is going to repeat, then you start knowing to look for the repetend in your problem. All right, write 0.555555 as a rational number in the form of a over b. Now, this is an interesting process. So I've got examples for you. I've got typed up examples, and we'll do some by hand as well. So here we go. Again, 0.5 is a rational number in the form a over b. In other words, they want this as a fraction. So let x equal 0.5. So that x is 0.55555, okay? They wrote it out. Notice the ellipsis dots to imply that it goes on forever. Multiply both sides of the equation, x equals 0.5555, by 10, okay? Then it tells you why to use 10, and this is going to be the important part of this process. Use 10 since there is one digit that repeats, okay? It's going to say this again in a minute. If there were 2 digits that repeat, we would multiply by 10 squared. If there were 3 digits that repeat, in other words, the repetend was 3 digits, we'd multiply by 10 to the third. If there were 4 digits that repeat, you see the drill, we'd multiply by 10 to the fourth. So right now we're multiplying by 10 to the first because the 5 is the repeat. Now look, when you multiply both sides by 10, you just multiply by 10 over here and 10 over here. That's going to give you 10x equals 5.55555 repeating. Correct? Now I'm going to go to the next page, show you what to do next. All right, so there is what we have after we multiply by 10. Notice the next step. I'm going to highlight that in a different color. You subtract your original equation. Remember, we wrote down x is equal to 0.555. You subtract the original. Notice what that gives you. 9x equals to 5. We know 10x minus 1x is 9x. And 5.5 repeating minus 0.5 repeating is 5. Then you divide both sides by 9. And boom, there's your answer. 0.5 repeating is 5/9. You will have to do this in the homework. Okay? This is an interesting process. So, what do I have next? Do I have another example? Now, this is another way to do it. This showed up in the PowerPoint, and y'all, I have yet to decide. You may come back and go, I know why they did this, but I'm not sure why they gave you this example as well. This is a different process, okay? But it works, and so I think the argument is just to see that there's another way to do this exact same problem, but let's go with the first way that I showed you to do these just as a standard algorithm for knocking this out. So this time, just follow me along. S is equal to, again, the same number, 0.5 repeating. Now, we know that that's the same as 0.5, and I'm being lazy when I read it like that, right? When I read this one as 0.5 repeating, I have no choice, because that 5 goes on forever. It doesn't stop. So I can't say it's the thousandths or the 10,000ths. But now when I read what's on the right, I can read this. This is 5/10ths plus 5/100ths plus 5,000ths plus 5/10,000ths, and that goes on forever. Okay, now notice what they did. Okay, they multiplied both sides of this equation by 1/10. Now, if I multiply the blue here, the right side by 1/10, does that not move the decimal to the left for each one of these? So 5/10ths turned into 5/100ths. 5/100ths turned into 5,000ths, on down the line. Well, they did the same process. They subtracted they actually took, this time, I'm saying it backwards, they took the original expression, what we have at the top of the screen here, and it subtracted the one that we multiplied by 1/10. So it's kind of like the opposite of what we did before. Notice that gives you 9/10 s is equal to 5/10. You divide by 9/10 and you still get 5/9. So I think the argument is to show you this done two different ways. But again, the first way is the way we're going with it, okay? It's a little bit easier to teach you steps to get this done. And here are the steps, okay? In general, if the repetend is immediately to the right of the decimal point, first multiply by 10 to the m power, where m is the number of digits in the repetend. This is what I told you earlier. If there's just one digit, you multiply by 10 to the first. Okay, so that would be for one digit. If there were two digits that repeated, you'd multiply by 10 squared. If there were three digits, you'd multiply by 10 to the third, and so on. Okay, it says, suppose the repeating block does not occur immediately after the decimal point. It can happen that you have a digit or two in the tenths, hundredths, thousandths place that is not part of the repeating block. Okay, a strategy for solving this problem is to change it to a related problem we know how to solve. That is, change it to a problem where the repeating block immediately follows the decimal point. And you might hear me say that and read it with me and go, huh, don't worry, I'm going to show you. Do not stress. But let's go with another fairly straightforward, simple problem. And then we'll do one that involves what we've got in the blue block down here. So here's a pretty straightforward problem. We're supposed to write 4.23232323 repeating forever as a rational number. Okay, let's try to do this. So how do we start? Remember what we're supposed to do? First of all, make it an equation. So we would have x, I feel like my pen's not going to write. It's not. And I pressed it, I promise. Okay, x is equal to 4.232323. You may be wondering, how far out should you take it? A few places. It doesn't matter too much, but make sure you take it out. Don't just, don't just do a couple places. All right, so what do we do next? Well, tell me about the repetition. So the repetend is over two numbers. So again, since the repetend is two digits right here, I'm going to multiply both sides of this equation by 10 to the second power. So we're going to multiply by 10 to the second power. Well, 10 to the second is 100. And you can write it as 100 or you can write it as 10 to the second. It doesn't matter to me. I'm just going to write 100. So that gives me 100 times x is equal to 100 times 4.232323. Again, that's repeating forever. Now let's simplify that. I'm going to use all green this time. So I have 100x on the left-hand side. Now when I multiply this decimal by 100, does it not scoot the decimal two places to the right? And you should say, yes, it does. Okay, and then this 23 again goes on forever. Okay, now do you remember what we're supposed to do next? We're supposed to subtract the original equation. I'm going to subtract that. So I'm going to do minus x over here and minus 4.232323. Now let's subtract like we're supposed to do. Okay, so on the left we've got 100x minus 1x. Remember, there's an implied 1 right there. That's going to give me 99x. On the right, I've got, well, first of all, the decimal part. Let's just look at just the decimal part. That cancels, with that. 423 minus 4 is 419. Didn't mean that to be the purple color. Now what do? I say x is equal to 419/99. That is that decimal in fraction form. You could even type that in your calculator to prove it to yourself. So 419 divided by 99 gives me 4.2323232323. So you can be satisfied when you do it. You'll know you'll get your original decimal back, and it'll be a repeating decimal. Now, are you following why you multiply by 10 squared instead of 10 to the first? Your goal is to get, let's use another color. Your goal is to get all of this part over here to match up exactly so the decimal part cancels out. Okay? That's what you're trying to do. You guys, I realized I squared off the wrong part, so I had to re-square my purple part. But the part that's crossed out, that's what I should have squared off. You want that part to cancel out. That's exactly why we multiplied by 100 and not 10. So let's do one more problem that involves that extra issue that we had squared off in blue just a second ago. Alright, so we're supposed to write 2.345. What's repeating? Always pay close attention to what's repeating. 4-5 is the repetend, not 3-4-5, because the bar doesn't go over the 3 also. So only 4-5 is the repetend. So we know we have to multiply by 10 squared. But here's the problem. That 3 is in the way. So you know what we're going to do? The first thing we're going to do is turn it into a problem that makes sense to us, that follows the guidelines we had in the first part. I'm going to multiply by 10 to start with. So I'm going to say x is equal to 2.3454545, goes on forever. And I'm going to multiply both sides by 10. So that's going to give me 23.4545. I can't write it. 45. Just keep writing it. There we go. 45. And that goes on forever. Now I can see that the repetend is directly next to the decimal point. When that's the case, and again you have 2 repeating digits, we can multiply both sides by 10 squared. So I'm going to multiply by 10 squared here and 10 squared here. And I think I've got it all typed up after that. So I'm going to go ahead and do that so you don't have to suffer through this, because I know you could do the rest of it. So that 10n, that's what we did just to get it lined up and scoot that 3 over. And then the 100 was the next thing we multiply. Now if we multiply by 100 times 10, that's multiplying by 1,000. That's what they have written right here. And that gives us 2,345 with the 4-5 repeating. And then we subtract not the original, but the original one that we were working with. So don't go back and subtract x. Go back and subtract the one that you multiplied by 10, because that got it lined up the way we needed it. Because again, it had that extra 3 right there, and we had to scoot it over out of the way. You only want the repetend on the right of the decimal, not any other numbers over there. Now, when we subtract 1,000 minus 10n, you get 990n equals 2322, okay? And again, what is that? That is the 2345 minus the 23, okay? The decimal part cancels out. And then you divide by 990. Turns out you're going to reduce this one likely to lowest terms every time you have to do this initial multiply by 10 to scoot everything over. And that gives you that irrational number. Okay, it's an interesting process, but it does show it is possible to go back and forth from irrational to decimal and again. Okay, now here's the surprising result. This is fun. So we're supposed to write 0.999 repeating as a rational number in the form a over b. Now let's do it by hand just to practice the process. So we would say x is equal to 0.9999, and that goes on forever. Remember what we're supposed to do? The repetend is just one digit, so we're going to multiply both sides by 10 to the first, because there's just one digit. So that would give us 10x is equal to 9.999, repeating forever. Then we're supposed to subtract the original expression here at the top, or equation. So x equals 0.9999. We're minusing that from both sides. 10x minus 1x is 9x. 9.999 repeating minus 0.99 repeating is 9. And then what do? We divide both sides by 9. We get our pen to work. That's what we do. We get our pen to work, divide both sides by 9, and I get x is equal to 1. So that means, this is crazy as it could be, 0.999999 forever and ever and ever and ever is really just the number 1. These are equal. You'll have some interesting homework that deals with that. Fun, huh? Now, here it is typed up for you. It looks so much neater. So 10n times 9 repeating, you subtract the original equation. They used n's instead of x's. Is that okay? Oh, absolutely. So that gives you 9n equals 9, divide both sides by 9, and you get n is equal to 1. And again, the surprising result is that 9 repeating forever is actually the number 1. Now, what if we have to order these things? Okay. You remember smallest to biggest or biggest to smallest? Make sure you read your directions there. So ordering repeating decimals in the same manner as the terminating decimals. Hey, just line everything up. If you're comparing these two decimals, write it out. So 1 with the repetin 3, 4, 7, 8. They just wrote out 3, 4, 7, 8, 3, 4, 7, 8. You could write it out further if you needed to. And then 1, 3, 4, and then the repetin here is 7, 8, 2, 1. Just write that out. And then you compare. You start with the leftmost number. Line it all up. If they match, you keep going to the right until one is larger than the other, which means that the first number listed is a larger decimal than the second number listed. And they wrote that down here. 1 with the repetin 3, 4, 7, 8 is greater than 1 with the repetin 3, 4, 7, 8, 2, 1. Example 12, find a rational number in decimal form between 0.35, 35, and 0.351351, starting from the left. The first place at which the two numbers differ is the thousandths place. Okay, so notice, it's almost like comparing them, right? You do exactly the same thing. So the zeros match, the threes match, the fives match. All of a sudden, this one, the 3, is bigger than this one is a 1. What I like to do is write them next to each other in order. So we have, if we were looking at a number line, 0.351351 is to the left of 0.353535, like that. Now we're trying to find something that fits in the middle. Okay, now where do they differ? And that's what it's got highlighted. So that's that third place, right? This value was less than this value. Now, what would fit in the middle or between those? Okay, well, this is 351 and this is 353. So what about 352? Right? And that's what we have right here. And you could even find other numbers. So you could say 3521 or 3522. They've even got listed 3514, right? That's bigger than 3513, 3514, or 3515 is still smaller than 353. So there are infinitely many decimals between there. You will find homework that involves this as well. But stacking them up to find out where they differ, writing them next to each other, I think is a good way to handle it because it helps you visualize what's in between. I just realized that was my last slide right there. This is the shortest video ever, right? I really think I've covered everything in this section fairly well. This homework, as you know, is no different than any other homework. It really makes you think hard about what's going on. I could lecture more and more, but it's really something you're going to have to sit with and spend some time with, and I think you'll glean a lot from doing this homework and maybe even suffering with it for a few minutes. So again, be patient with yourself, be patient with me, and if you struggle a whole lot, reach out and let me help you, okay? So I hope you have a wonderful day, and I will see you back for section 7-4. You have almost gone through all of this course. Hang in there.